Hi, in this given question, we are solving a problem on faulty barometer. Now, in the first diagram, he says that that actual atmospheric pressure is 76 centimeter, but the barometer is showing 74.5 centimeters. So we have to apply Boyle's law here. Boyle's law means PV is equal to constant. See, pressure is measured as rho g h. Rho g is a constant, so we can talk pressure in terms of height. And volume is A into L. A is a constant, so generally this can be written as h into L is equal to constant. Now he says that when the barometer reading is 74, what is the true reading actually? See, basically what happens is, if there is any leakage from this mercury inside this, so here what happens is this trapped air increases actually. So in the case of faulty reading, actually this trapped air increases. So we have to see what is the trapped air. In the first scenario, the correct reading was 76 and the faulty reading was 74.5. So this is the additional trapped air. Into length we have to take. Length means we have to take the length of this trapped air. Okay. So that total length is 90. So 90 minus 74.5. Okay. In the second situation, we don't know what is the correct reading. So it is H minus, the reading on the barometer is 74. H minus 74 into the new length. New length will be 90 into this much. 90 minus 74 we have to take. So this leads to 1.5 into, and this is 15.5 is equal to H minus 74 into 16. So H minus 74 is equal to 1.5 into 15.5 divided by 16, or from here we can calculate the value of H. This is how faulty barometer problems are solved. Thank you.